Experience the next step in AI 3.0 with Autonomys Network. This proof of concept demo highlights an agent operating in a trusted executed environment, leveraging retrieval augmented generation from securely stored data within Autonomys DSN. Built on Autonomys decentralized 3-stack solution, DSN, data access, and private compute, this demo showcases the potential for human-centric, secure, and customizable AI deployment. Hello everyone, welcome to another demo of Autonomys Network. In this demo, I wanted to present our new proof of concept agent, which it is confidential RAG agent. Behind the scene of this agent, there is a TEE running, and we are using H100 and AMD CPU. So all of the computation, whether it is LLM or RAG or the vector databases, all of them are inside the TEE, although the user have the flexibility, for example, only use the LLM, but doing all of the RAG things on their local machine, or have a hybrid model using combination of LLM and OpenAI, for example, for calculating and generating the embedded models. So we are here with a lot of options ahead of us. One of them, I'm just using everything end-to-end on the TEE. So the vector database, the RAG, the embedding, and the LLM, all of them are inside the TEE. For the LLM, I'm using Llama, and with Llama, basically using the Llama model, 11 billion parameters, the vision version. And for the vector database, I'm using Chroma. And the embedded model is also one of the open source models inside the Hugging Face that is running on the TEE. So let's get started, and we will start by checking and sending a request to receive the attestation from the TEE. So as you can see, the attestation is retrieved, and it is showing to us that the services, for example, right now, because the TEE is running on the Azure, is a cloud-based TEE, and you're seeing that, okay, this NVIDIA is basically running on this machine. And as you scroll down, you will see all of the steps. For example, the measurements that you need to know about the TEE are getting verified. And if you scroll down, you will see the signature from the TEE, and you will see that signature is verified, the nonce is verified, and you will end up with two JWT tokens. So basically, these JW tokens are compressed version of the certificates and the report that we got from the, for example, the framework, the model of the GPU, and etc. So if, for example, you go to the JWT decoder and doing the decoding of this JWT, you will see the attestations, the driver, and bias, and etc. Basically everything that you need, and generally everything that you will find in an attestation. Okay, perfect. So right now, the things that I'm going to show is that when you want to upload a data to the DSN, this data will be encrypted with TEE public key. And when you send a request to the TEE to generate a new conversation or just a simple prompt to the LLM model, the TEE will retrieve the file from the DSN and decrypt it with the private key, which is stored securely inside the hardware. So no other parties, even person who is running the model, has access to it. And after that, your LLM or your RAG model will be context aware of the document that you want to talk about. Also, we have a web search here. If you wanted to do Google search, for example, you can, and you can feed it to the vector database after that. Everything will work seamlessly. Okay, let's get started. And I'm going to ask something crazy. For example, what is this say this is about? So we're sending the request to the TEE LLM, to the LLM which is running inside the TEE, and okay, it doesn't know anything about Said's thesis, but let's download my thesis. Okay, I'm going from here to download. Okay, this should be thesis. I'm uploading, first I'm encrypting this file with the TEE public key. So if we grab this CID, come to auto drive, as you can see, this is the reason is because I was testing this before, of course. So I have a couple of things, but this message pack, it's an encrypted file. So if you download this file, which basically you can, but you're not able to see what is inside. Okay, so when I'm sending the request to the TE, basically I will just tell the TE, okay, this is the CID, just call the DSN and retrieve the file and start decrypting the file with your private key. Perfect. So the file is retrieved and also decrypted securely on the TEE. If I ask my question again, just basically wanted to copy and paste. Perfect. Now we are seeing the power of RAGs. The TEE right now we are able to see basically it actually knows about my thesis, which basically was based on intolerant erasure coding for blockchains. So we can also do web search, for example, Autonomys Network. So good. We are seeing that it's talking about Dr. Chen Peng, features the speaker. Okay, I can send it to chat. The thing that just happened is that I feed it to the vector database as well. So if I ask about, give me summary of Autonomys. Okay, not bad, but yeah, I should mention again, the model is Llama 11 billion parameters, so we shouldn't ask too much. But let's just do another thing. Please private tweet. Thesis. Perfect. So there is another option that you can use, is that you can back up your vector database and upload it to the DSN. And you can encrypt it, you can just keep it decrypted. We have a feature of encrypting and setting a password on a auto drive. So when we launch, you can just try it out by yourself. I hope you enjoy it. Have a good one.
Thank you for exploring this POC with us. Powered by Autonomys DSN, data access, and private compute, we are driving secure, personalized, and decentralized AI solutions that foster transparency and collaboration. Follow along as we continue to build the foundation layer for AI 3.0.